Okay, let's do problem 200, number of islands. Here we are given n by n to the binary grid, where 1 represents land and 0 represents water, and we have to return the number of islands. So island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically, not diagonally, and we may assume that 4 edges of the grid are surrounded by water. So this is the example we have, and then we have 1 island here, we have 2, and then 3 islands in total. This is example 2, so the output is 3 as expected. So the approach we're going to take is we're going to traverse the grid row by row, and then when we see 1, we do know that there's island here, and then we're going to perform DFS for 4 different directions. And then as we do that, we're going to change 1 to another number. We can call it 2. And then when we apply DFS, all of them will be 2. So we only apply DFS if the value is equal to 1. So there will be some sort of counter. It will be initially 0, and then when we see 1 island, we increment the counter. So when we apply the DFS in 4 different directions, the function will look like this. So we would have some recursive function DFS. We will have 4 of them. And then we're going to pass in grid for all of them as well. And then we have to go to the left, so it will be I minus 1 and then j. And then we have to go to the right, so I plus 1, j. And then we have to go up, j plus 1. And then we have to go down, j minus 1. J minus 1 is up. So, but if we just apply this DFS directly, it's not optimal, as in we have to compute for something that's not necessary. So we can apply some conditions. So this is I minus 1, so it's going to the left. So we can check for the boundary, which is greater than or equal to 0. And then this one is going to the right. So we can check if it's less than the row length. So it will be less than grid dot length. And then for this one, it's going down. So we can check if it's less than the column length. So it will be less than grid I dot length. And then for this one, it will be going up, so we can check if it's, well, whatever it is, we can check if it's greater than or equal to 0. And then we can apply same condition for all of them, which is grid whatever it is, so for this one it will be I minus 1 and j. For this one it will be I plus 1 and j. We can check if they are equal to 1. We apply DFS. And in our DFS function, we need to have a boundary condition, which is fairly standard. So let's write down the code now. So it will be, we do need int counter is equal to 0. And for int I, so we're going to look through the 2D array, grid.length plus plus, for int j equals 0, grid dot I dot length, and then j plus plus. And we can say if grid I and j are equal to 1, well, let me check if it's integer or not. No, it's not an integer, it's a string, so we need to do 1. In that case, we call our DFS function grid and I and j, and then we increment our counter. And then at the end of the iteration, we just return counter, and then we need to write our DFS function. So public void DFS, it will take in character array of grid and int I and then int j. So let's check for the boundaries. So if I is less than 0, we return, so we don't need to do anything, or j is less than 0, or I is greater than or equal to grid.length, or j is greater than or equal to grid I.length. So that's our boundary condition. And so now, so we are at this point here, we need to change this one to 2. Well, it doesn't necessarily have to be 2, but the reason we are changing it to 2 is so that we don't have to revisit the same point. So with grid I and j will be 2. Sorry. And then we are going to apply this DFS function here. So if I minus 1 is greater than or equal to 0, and grid I minus 1 and j is equal to 1, we apply DFS grid and I minus 1 and j, and we have to repeat this 4 times. So let's do I plus 1. For I plus 1, we need to check if it's less than the grid length. Change to I plus 1. This becomes I plus 1 as well. The next one is I and j plus 1, so we need to check for j plus 1 is less than grid.I.length, and then I and then j plus 1. Next one is I and j minus 1. So j minus 1 is greater than or equal to 0, and then I and then j minus 1. All right, and then we can just have return function here. All right, let's run the test. Okay, there you are. Such a silly mistake. All right, let's submit. Okay, that's it.